Welcome back to the Deep Dive, where we take a stack of sources, extract the absolute most critical knowledge, and give you the competitive edge you need to feel genuinely informed.
Today, we're tackling a big one.
We really are. Our mission is to demystify one of the biggest hurdles in the modern digital world: web development. We're going to focus specifically on the front end.
And we're starting with a philosophy that comes straight from our source text, which is Coaching Website Development, Chapter 5.
What's the core idea?
It's simple, really.
Oh,
Code is not magic. It's just logic written beautifully.
I love that because that sentiment is just so crucial, especially for someone who feels, intimidated by all the syntax and symbols of code.
It is. I mean, when people hear full stack development, the front end, the part you can actually see, is often where that anxiety starts.
Right.
So today, we're stripping away that fear. We're going to show you that really at its core, front-end development is just a thoughtful assembly of structure, style, and sequence.
Absolutely.
Right.
And we are providing you with what is basically the ultimate shortcut. We're going to dissect the roles of the three fundamental languages. That's HTML, CSS, and JavaScript.
And maybe most importantly.
Yes, and most importantly, we're going to show you how modern AI tools have just completely transformed this process. They've turned what was a steep learning curve into something that's, well, an accessible, creative workflow.
So if you're in a position where you need to understand how sites are built for a meeting, or if you're maybe launching a personal project.
This is the deep dive for you. We're giving you that quick yet technically thorough knowledge.
Okay, so to set the foundation.
Yeah.
The front end.
Yeah.
What is it? It's everything the visitor experiences and interacts with right in their browser.
So the text, the colors.
Exactly. The text, the colors, the interactive buttons, any animations you see. It is, the palpable interface of the digital world.
Got it.
So our conceptual journey today, we've broken it down into 4 practical learning goals. First, clearly defining the distinct roles of HTML, CSS, and JavaScript. Second, understanding the mechanics of modern responsive design. Third, leveraging AI for both generating code and for advanced debugging.
And the last one.
And finally, you'll walk away with a clear blueprint for creating a working, polished layout.
Okay, let's unpack this with a framework that makes these roles instantly clear. The source material uses this wonderful analogy that I think is really helpful.
The theater stage.
The theater stage. It helps us visualize how 3 very distinct elements collaborate to create a single, unified performance.
And this analogy, it just works so well because it moves the discussion away from abstract lines of text and into a tangible visual space.
Yeah.
We're basically setting the scene, decorating the stage, and then directing the actors. If you can understand these 3 components, you really understand 90% of front-end architecture.
Let's break down that holy trinity then, using the stage analogy.
Okay, so we begin with HTML. This is the structure. In our analogy, this is the stage and the props.
Okay, the physical things.
Right. HTML, which stands for Hypertext Markup Language, is the solid, unchanging foundation. It dictates the existence and placement of everything. A heading goes here, an image there, a list of items on this side.
So it's the blueprint.
It's the blueprint that ensures everything has a fixed physical location before any styling or movement is added. Without that HTML structure, you just have a blank screen.
An empty stage. Then we apply CSS, the style. This is the fun part, I think, the design layer.
This is where the personality comes in.
In our analogy, CSS cascading style sheets, that represents the lighting and the costumes. It transforms that plain black and white structure into a professional visual experience.
It's what determines the font, the background color, the spacing between elements, and just the general mood of the page. It makes the stage look beautiful and, thematic.
And finally, we have to make it do something. So we activate JavaScript, or JS, which controls the interaction.
This is the choreography. These are the actors' movements. JavaScript breathed life into that static scene.
So it determines what happens when I click a button.
Exactly. Or how an image gallery rotates, or what content loads when you scroll to the bottom of the page. It's the logic that governs all the dynamic behavior of the interface.
It's the difference between a photograph of a stage and a live play. You need that interaction to move from just a passive presentation to active functionality.
That's a great way to put it. So let's deepen our understanding of HTML first. While a beginner often just focuses on, the visual outcome, the modern web developer has to think about something called semantics.
Semantics, so meaning.
Meaning, HTML tags are not just about formatting. They are about communicating meaning.
So when we look at simple Knurb, like H1 for the main title or P for a paragraph, that's just standard structure. But what's the significance of using one tag over another beyond just making the text look bigger or smaller?
Ah, that's where semantic HTML comes in. It's a key insight if you want to be truly well-informed, instead of using a generic kind of meaningless tag like div for everything.
Which a lot of beginners do.
Yeah. Which a lot of beginners do. Good developers use tags that actually describe the content's purpose. For example, using nav for navigation links, or header for the site masthead, or article for a self-contained piece of content, like a blog post.
So wait, why does the browser care if I use a div or an article? I mean, on the screen, they look completely identical.
That's the thing. The browser doesn't really care. But Google search bots do. And more importantly, accessibility tools like screen readers care deeply.
Ah, okay.
Semantic tags provide context for that software. A search engine ranks an H1 higher because it understands that tag marks the main topic of the page. A screen reader can navigate the page efficiently because it recognizes a nav tag at a list of links, not just a random collection of text.
So it improves your SEO.
Massively. And it ensures users with visual impairments can actually access your content properly.
That immediately elevates the conversation beyond just, simple definitions. And speaking of clarity, the source really emphasizes the importance of neat code and indentation. Why is that? I mean, if the computer ignores the extra spaces, why does indentation matter so much?
The browser parser it's highly forgiving.
Yeah.
You're right. It can read HTML all on one single line and still render the page correctly.
Mm.
But code is written once and then read dozens of times by humans, by your collaborators, or even by your future self 6 months down the road.
I've been there.
We all have. The source quote, "Good formatting helps your brain think clearly." It just hits the nail on the head.
So it's for us, not the machine.
It's for us. When you're nesting tags like putting a list of items inside a menu, which is inside the header section, proper indentation, helps you visually track which element is the parent and which is the child. When you're debugging, a misalignment can immediately signal a potential structural error. It's a habit of discipline that really separates hobbyists from professional developers.
Okay, so we have our structurally sound, semantically labeled HTML skeleton. Now let's add the aesthetic component. CSS, cascading style sheets. This is that transformation layer, adding colors, fonts, and sophisticated layout.
Right. And the word cascading in CSS is maybe the single most important concept to grasp here. It explains the hierarchy of rules.
What do you mean by hierarchy?
Styles cascade from general definitions like the default font your browser uses, down to more specific rules like a style sheet we wrote ourselves, and finally down to ultra-specific rules like a style written directly inside an HTML tag.
So if I set the entire page body to have a blue background, but then I tell one single paragraph on that page to have a gold background, the gold rule wins.
The gold rule wins because it is more specific and it's lower down in that cascade.
Ah.
And that leads us directly to another key concept, specificity. If two conflicting rules apply to the same element, CSS has to figure out which rule is more specific. It does this based on a weighted hierarchy. IDs are more specific than classes, which are more specific than simple tag selectors.
And understanding that hierarchy prevents that classic beginner frustration of, why isn't my style working?
Yeah, actually. It's almost always because a more specific, probably forgotten rule is overriding it from somewhere else in the cascade.
Let's look at the style application example from the source material. We see the general setting, body background color, hashtag 5555, font family, open sans serif, the hef-free. So that's like the default lighting for the whole stage.
That's the base layer. And then you see the focus styling on an interactive prop dot button, background, gold, color, black, padding, 10px.
And notice the padding, 10px. This isn't just about color, it's about spacing. This is really the gateway to layout control, isn't it?
It is. Historically, creating complex grid-like layouts with CSS was. It was a painful, highly technical chore.
Oh, I remember float-based layouts, a nightmare.
A total nightmare. But modern CSS is completely different. For our audience, if you're aiming for up-to-date knowledge, you need to know the current standard for layout.
And that would be?
The standard is no longer complicated floats or absolute positioning. It is Flexbox and CSS Grid. We have to mention them.
Okay, Flexbox and CSS Grid. What's the difference?
Flexbox is excellent for arranging items linearly, so in one dimension like distributing items horizontally in a navigation bar. CSS Grid is for arranging items in 2 dimensions, so columns and rows, like laying out a full page.
So Grid is for the whole page layout. Flexbox is for components within that layout.
That's a great way to think about it. These modern tools allow you to achieve professional, adaptable layouts with, dramatically less code complexity than even 5 years ago.
Hmm.
And this is crucial because when you use an AI prompt like make a 3-column layout, the AI is almost certainly using Flexbox or Grid under the hood.
Right, so you need to know those terms to understand what the AI is actually giving you.
You do.
So it's a key distinction. We aren't just styling the button. We're using concepts like Flexbox to decide where that button should be relative to everything else.
And the power of AI here becomes obvious. You ask it, add a gold header and green background to my web page, and it handles all the syntax of selectors and color codes for you instantly. It translates your design concept into a specific executable CSS rule.
Okay, so we've built the static structure with HTML, and we've applied the beautiful responsive styling with CSS.
Now we need the actors to move. We need the stage lights to change color based on audience input. This transition brings us to the dynamic engine of the front end, JavaScript.
This is where it gets really interesting because we are moving from just presentation to actual functionality and event handling. But there's a critical narrative glitch we need to cross here. How does JavaScript, which is a separate language, actually know that the gold button from our example even exists in the HTML?
That connection is managed by something called the Document Object Model, or the DOM.
The DOM.
The DOM. It's the browser's internal, structured representation of the HTML page, and it's organized like a tree. Think of it as the Backstage Manager's detailed map of the stage. Every single prop, every light, every piece of text is an accessible object on that map.
So when JavaScript wants to change the text on a heading, it doesn't edit the raw HTML file itself.
So it uses the DOM to find that specific object in the browser's memory and then manipulates it.
So it's interacting with a live model of the page.
Exactly. JavaScript interacts with the DOM to read, add, or change elements dynamically. This is the core mechanism that turns a passive page into an active conversation. The source's analogy really rings true here. JavaScript is like body language. It turns a quiet page into a lively one.
Okay, let's analyze the provided JavaScript snippet in the context of the DOM. It reads document.querySelector button.addEventListener click function alert. Hello, welcome to my website.
Let's break that down. The first part, document.querySelector button. That's JavaScript telling the DOM, hey, go find the first object tagged as a button on your map.
So it's a search command.
It's a search command. Once it finds that button object, the next part, addEventListener click, is a pure instruction. It says, okay, now wait and listen for a specific event, a click event to happen on this element. This is what we call event handling.
So it's just sitting there waiting for me to click. And the final part, the function, that defines what actually happens when the event is triggered.
Correct. In this basic case, it just pops up an alert box. But in a real-world scenario, that function might do something much more complex, like calculate a shopping cart total, validate a form, or load new content from a server without reloading the page.
And that leads to a deeper concept you mentioned, right? Asynchronous operations.
Yes. Most powerful JavaScript functions aren't immediate. They involve waiting for a user click, or more often, waiting for data to come back from the server, the backend.
But the page doesn't freeze while it waits.
That's the key. It continues to function. This asynchronous nature is what makes modern web applications feel so fast and fluid. The choreography is running smoothly in the background while the actors await their next cue.
And if that choreography, the JS, is complex, we need to make sure the stage, the HTML and CSS, can adapt instantly, which brings us right to the necessity of responsive design.
Responsive design it's no longer a luxury. It's a non-negotiable requirement for any modern website.
Because everyone's on their phone.
Exactly. With a majority of internet traffic now coming from mobile devices, a site has to adapt seamlessly to every single viewport, from a tiny watch screen to a huge desktop monitor.
The stage needs to be flexible enough to work beautifully in a large concert hall or a small black box theater. And the mechanism for this flexibility, as we noted before, is the CSS media query.
Yes, a media query allows us to apply conditional styling. It means we aren't creating two separate websites, one for desktop, one for mobile. We're creating one cohesive design that knows how to adapt its own rules based on the physical conditions of the screen.
Let's analyze that example from the source again. At media, max width 600px, 600px, font size 20px, button width 100%.
So why 600 pixels specifically? That 600 pixel threshold is a really common breakpoint because it's generally where a modern smartphone screen width ends, more or less.
Okay.
The rule is basically saying in plain English, if the viewport is 600 pixels or narrower,
Then make the text size smaller, 20px, and make sure the button fills the entire available width, 100%.
So it's more usable on a small screen.
Right. But the key concept here is not just making it responsive, but designing mobile first.
Okay, what does that mean in practice?
It means instead of designing a sprawling desktop site and then trying to cram it all onto a tiny phone screen, you start with the constraint of the mobile screen. You ask yourself, what is the absolute necessary content and functionality? You design that core experience first, and then you use media queries to add complexity and visual flair for larger screens.
That feels like it shifts the entire philosophy from just resizing a large page to enhancing a small, focused one.
It does. It forces developers to prioritize content from the very beginning, which improves the overall user experience regardless of what device they're on.
Which brings us back to that idea of the integrated experience.
Yeah, exactly.
So what does all this synergy mean when we look at the big picture? We are building an integrated user experience where design and content meet code.
And the source illustrates this perfectly with that triangle diagram where everything converges into the core concept of experience. We have the three pillars: structure, HTML, which is the literal foundation,
Motion, CSS, which dictates the mood and the visual feeling.
and rhythm, JavaScript,
Yeah.
which controls the timing, the dynamic responsiveness, and all the functionality.
And if the structure is bad, say, the HTML is missing those important semantic tags, the rhythm will be slower, and the emotion might be misunderstood by things like search engines.
Precisely. If one pillar fails, the whole experience collapses. If the CSS is heavy and bloated, the page loads slowly, which destroys the rhythm. If the JavaScript logic is flawed, the button doesn't work, which frustrates the user, no matter how beautiful the CSS is.
So good front-end development is the delicate harmonization of these three layers. It's about creating a coherent, engaging, and functional path for the visitor.
That's the goal.
Okay, now let's pivot to the tool that makes achieving this integrated experience dramatically faster and more accessible for everyone: AI coding assistance.
This is the technology that effectively removes that fear barrier we talked about for new developers.
And the historical reality was that learning the detailed syntax of three languages all at once it was overwhelming.
It was a massive hurdle. AI fundamentally shifts the focus from memorizing syntax to understanding logic and intent. It automates that tedious translation from a human concept into computer code.
The source details 4 main capabilities that remove that complexity. Let's expand on these. First, AI can generate full HTML, CSS, JS templates. This means no more staring at a blank text editor.
Which is critical for momentum. A beginner can get a functional structured page in seconds. Second, and this is so vital for learning, AI can explain every line in plain English.
An infinite patient tutor.
Exactly. It's built right into your code environment. If you copy a complex CSS layout that uses Flexbox, you can just ask the AI, explain the logic of this Flexbox layout, and it will break down the specific properties for you one by one.
Third, and this is where AI saves hours of frustration, it can debug and fix errors automatically. Typos and syntax errors are instantly flagged and often corrected for you.
And fourth, it translates those simple conceptual prompts, like make the header stick to the top of the page as I scroll, into precise actionable code.
Okay, but that said, this power introduces a new kind of risk, doesn't it?
Yeah.
If the AI generates all the code for us, what is the inherent risk of code bloat or even generating insecure code, especially for a beginner who doesn't yet know how to audit the output?
That's a sophisticated and a very necessary question.
Yeah.
We cannot just assume AI-generated code is perfect. The risk of code bloat is very real.
Why is that?
AI tends to generate highly verbose, sometimes redundant CSS or inefficient JavaScript because its main priority is just getting the function to work. It's not focused on optimization.
And that slows down the site.
It slows down the site, negatively impacting load time and your SEO. For a beginner, the solution is really twofold. First, use highly specific prompts to reduce ambiguity. Second, and this connects to what we'll talk about later, you have to understand the rules of clean code so you can audit the AI's output, deleting unused snippets and simplifying selectors.
So the human is still the editor.
The human is still the editor and the optimizer. Absolutely.
I appreciate that the source normalizes the process of making mistakes. Errors are just inevitable, even for experienced coders. But for a beginner, an error can be a catastrophic roadblock.
It can lead to instant paralysis. I still remember spending an entire weekend tracking down a single misplaced semicolon in a nested function years and years ago, before AI. That kind of soul-crushing frustration is what AI really helps to eliminate.
The text describes AI debugging as instant, patient, and personalized coaching.
It is. Instead of searching Stack Overflow for hours and trying to adapt someone else's solution, you can just ask your AI, why is my button turning green but not actually navigating to the next page?
And what would it do?
The AI immediately analyzes your specific JavaScript and points out that, for example, you forgot to include the prevent default function, which stops the form from submitting before your JavaScript has a chance to execute its action.
This means errors become immediate learning points. The AI is teaching you specific syntax and logic rules in the exact moment you need them, reinforcing the structure of the language rather than just leaving you stranded.
That's the real power for learning.
Okay, so to put this into practice, the source provides a curated list of tools, all categorized by function and target skill level. Let's detail these, keeping in mind that free tiers are available for all of them.
Starting with what is probably the essential beginner's environment, Replit AI.
What's Replit?
Replit is an integrated development environment, or IDE, that runs entirely online in your browser. Its core benefit is the instant preview and deployment. You write the code, you see the result live side by side, and you can instantly publish it with a single click. It's perfect for the person who wants minimum setup time.
Okay, stepping up in complexity, we have GitHub Copilot.
Copilot is a bit different. It's an AI assistant that works inside professional code editors like VS Code. It doesn't generate entire pages based on a paragraph prompt. Instead, it provides highly intelligent, real-time code suggestions as you type, filling in the next line or completing entire functions for you.
So it's more for someone who's already writing code?
It's excellent for intermediate users who are already familiar with the syntax, but just want to accelerate their workflow.
Then there's V0 by Vercel. The name Vercel is important here.
Yes. Vercel is a specialized platform for deploying modern web applications. V0 is their generator tool. It converts plain English prompts into functional, highly sophisticated code using modern frameworks like React. And it's styled with something called Tailwind.
Tailwind CSS.
Right. Tailwind is a utility-first CSS framework. So it's not traditional CSS. It's a way to style elements very quickly using predefined classes. V0 is a massive shortcut for building truly polished components, making it ideal for the beginner to intermediate user who's really focused on aesthetics and speed.
And finally, Cursor AI Editor.
Cursor is another IDE, but it's focused specifically on the conversational aspect of coding. You can highlight a complex section of someone else's code and just ask it, what does this chunk of CSS do? Or can you refactor this JavaScript function to make it cleaner for me?
So it's for understanding code, not just writing it.
Exactly. It's designed to deepen your understanding of unfamiliar code, making it an excellent resource for learning from complex templates you might find online.
With these tools in hand, the process of launching your first website is radically simplified. Let's walk through the source's four-step beginner workflow using the most accessible tool, Replit AI.
Okay, step 1. Open Replit AI. Right away, you bypass all the local environment setup, which can often be a complex hurdle in itself.
Step 2. Type a specific project prompt. And specificity here dictates the quality of the output.
It really does. The example provided is great. A simple 3-section website about AI education in Pakistan. That gives the AI explicit structure, 3 sections, gives it content, AI education, and even a geographic focus.
Step 3. Let AI generate the HTML, CSS, and JS. This is that instantaneous creation of the stage, the lighting, and the basic choreography. You now have a complete working code base in seconds.
And step 4, and this is crucial, preview the page and manually edit the text and content. This is where the human element comes back in. You have to replace the generic placeholder text with your specific voice, your data, and your imagery. The structure is built, but the personality is injected here by you.
And the final action. Publish instantly using Replit's hosting link. You have successfully gone from a concept to a live, deployed website in minutes, not days.
And this final step circles right back to practical necessity. The key tip from the source must be adhered to. Always test on your phone. If it looks good there, it looks good everywhere.
So you're adhering to that mobile-first philosophy even in testing.
You have to. It ensures usability, which at the end of the day is the cornerstone of good design.
Okay, we've generated our code, we've put it live. Now we move into the application phase, the refinement, where knowledge connects to critical review and long-term sustainability.
Right. This section addresses the inevitable glitches that are going to arise and how the beginner can use their growing understanding, assisted by AI, to handle them efficiently.
Let's discuss some of the common structural and stylistic pitfalls that can derail a generated page, even a good one.
The first and maybe most common structural error is missing closing tags. Forgetting to close a tag or a div tag.
And why is that so detrimental?
because it breaks the document object model, the DOM structure we talked about. The browser can't parse the code correctly, and your CSS or your JavaScript might end up applying to the wrong element entirely. The whole layout can fall apart.
And the fix.
The fix is instant with AI. You just ask it, find missing tags.
Simple enough. Next, a stylistic issue. Mixed font styles. This happens when different elements inherit default settings, or when the AI generates redundant CSS rules.
And the visual inconsistency immediately looks unprofessional. The quick fix here is centralization. You ask the AI, make the font uniform across the whole site.
So that forces the AI to check the primary body CSS selector.
Right, and it ensures a consistent font family rule is applied globally, overriding all those messy inherited defaults.
Third, overlapping elements. This is a big one. A layout problem, usually due to complex or conflicting flexbox or grid properties. Boxes appear on top of each other and the site becomes unusable.
This is often complex CSS to debug manually, but the natural language fix is simple. You just ask the AI, align all boxes neatly using Flexbox, or fix the layout issues on mobile. The AI reevaluates all the positioning logic for you.
And finally, we have to address the non-code issue that kills performance. Slow loading images.
This happens because users upload these huge 8-megabyte photos straight from their camera, but the website only needs a tiny 100-kilobyte version. The code is fine, but the assets themselves are too heavy.
And this severely impacts load time.
It destroys the user experience, that rhythm we talked about, and it actively hurts your SEO ranking because Google penalizes slow sites. Since this isn't a code problem, the fix involves external processing. You use tools like TinyPNG or Canva to compress the image file size before you upload it to your server.
Right.
Fast loading is paramount.
So while AI generates these fantastic templates, the source cautions that the true value comes from customization. The customization imperative has to be linked directly to the personality of the page.
Templates are a starting point, not a final destination. If you just use the AI's default colors, placeholder images, and generic text, you lose all credibility and brand identity.
You have to personalize it.
You must personalize the colors, replace the default structure with your own content flow, and crucially, inject your own unique voice into the text.
The coach's tip in the source encapsulates this approach perfectly. A website's beauty lies in personality, not perfection. This suggests we shouldn't spend 2 weeks trying to fix one tiny pixel alignment issue.
Exactly. Authenticity and unique content will engage a visitor far more than achieving pixel-perfect alignment. If you look at high-performing side projects or small business websites, they often have minor coding quirks, but they succeed because they have a clear voice and a powerful story. The code is simply the delivery mechanism for that personality.
And whether we write the code ourselves or have AI generate it, the foundation of long-term success is clean, readable code. This is not just a stylistic preference, it delivers tangible benefits.
Absolutely. The golden rules of development apply, regardless of who or what the author is. Clean code ensures the site loads faster because there's less bloat. It reduces bugs when you make future updates. And it significantly improves SEO because search engine crawlers can efficiently and quickly understand the structure and content hierarchy.
So what are the specific rules we must enforce, especially when we're auditing AI output?
First, use consistent indentation, which we established is for human clarity. Second, and this is critically important for AI-generated code, add comments.
Why are comments so important?
Because AI output often lacks human context. It doesn't know why you chose a specific font or why a certain function exists. Comments, which are marked with symbols like explain the intent of the code to the next developer or to your future self.
So even if the AI wrote a complex CSS rule, I should manually add a comment saying, this media query ensures the logo shrinks on tablets.
That's it, exactly. You are writing for people first. Third, name files clearly, index.html, style.css, main.js. This simplifies maintenance. And finally, and this is huge, delete unused code snippets. If the AI generated 3 buttons but you only decided to keep 1, you must delete the unused CSS and JavaScript associated with the discarded elements to reduce that bloat.
It all comes back to that principle from the source. Good developers write for people first, computers second.
That is the ultimate insight. Your browser will try to render almost anything, but a clear, well-commented code base is the key to collaboration, future updates, and performance.
To ground this entire AI workflow in a real, applicable scenario, let's revisit the story of Aisha. It really proves that technical anxiety is no longer a barrier to entry.
Right. Aisha, a 16-year-old entrepreneur selling handmade jewelry, needed a dedicated digital storefront, and she needed it immediately. So she bypassed the years of traditional learning and went straight to the AI workflow.
She used a powerful, specific prompt that combines structure, theme, and content. Create a simple online jewelry page with pink theme, contact button, and 3 product cards.
And in less than 5 minutes, Replit AI produced the working page. A full HTML structure, a soft pink CSS theme, and the basic JavaScript structure for interaction. The entire foundation was sound, leaving her to focus only on the content.
So she personalized it. She added high-quality photos of her unique jewelry pieces, and she wrote her own personal story. She published it instantly.
And the result? She shared her custom website link on social media and sold her first pair of earrings the very next day.
Her experience just validates the chapter's thesis. Code is not scary when AI explains it.
The barrier to entry has effectively evaporated. It's been replaced by immediate application and entrepreneurial opportunity, provided the learner takes the time to understand the underlying logic of HTML, CSS, and JS.
We have completed a really comprehensive deep dive into the front end, covering the conceptual stage analogy, the technical necessity of things like the DOM and CSS specificity, and the transformative power of AI tools like Replit and V0.
To quickly summarize the conceptual breakthroughs, front end is the visible interface. HTML provides that semantic structure. CSS manages style and layout using modern concepts like Flexbox and media queries.
And JavaScript controls the dynamic rhythm and interaction through the DOM.
And we also stress that the responsible use of AI coding tools requires customization and auditing for efficiency and to avoid bloat.
Our journey today was all about what the site looks like and feels like. The source material, however, points to the next unseen world: back-end development and data logic.
That is where your site thinks. It's what handles the secure storage of user data, processes transactions, and manages the server-side engine that drives the beautiful interface we just discussed today.
A deep dive for another time.
Definitely. But for now, you have the foundational technical fluency needed to build your stage.
So, to solidify all this knowledge, here's a final provocative thought, adapted from the source reflection questions. Consider the 3 elements: structure, style, and functionality. What was the easiest part for you to grasp conceptually?
And knowing now that JavaScript adds the body language to your page through these event listeners, what is one element of interaction, one small piece of functionality that you will explore first to give your newly generated page its rhythm?
Go give your stage some body language and see what happens.